Wish everyone a happy quality month. And I just have a brief presentation about our journey towards quality, and it's still very much an ongoing journey. I'll start with a brief introduction of my company so that we know who we are, what we do, and then I will go on to towards our journey. I think all of us are pretty much in a very similar journey, so I would really look forward to also hearing from you. How's your journey in towards quality, and learning from each other and exchanging ideas. Yeah. So briefly to introduce my company, Aditya Auto Products is one of the premier suppliers of automotive systems to the automotive market in India. We are having a very strong growth. We have a turnover of 620 crores this year. Just to put the growth in perspective, the last 2 years we have grown at a rate of 30% year on year. So it was 380, 480, and now 620 this year. We do several products for the automotive market, which is ranging from systems for doors, systems for hoods, systems for tailgates, and so we'll and we have totally 10 plants all over India. Next slide, please. Yeah. These are our main customers. About 60% of our turnover comes from automotive OEMs, and 40% also to tier ones, global tier ones. We also have a small roadmap to have a portion of our revenue coming from non-automotive sources. This is to explain some of our products. This is the main product, which is power windows. Most of, all our cars, we have these power windows. And just to give you an example of the technology in this, we start with the very traditional scissor lift type, which you see on the left. And today's state of the art is what you would see in the middle, which is the drum and cable, the cable type window lifters. And in the age of EVs, these power windows become much more critical because then there is no noise from the engine anymore. So what was an accepted criteria for customers, end customers before, suddenly people start hearing the power windows much better. And the parts have to go through a dramatic change. So noise is very critical, and the weight is very, very critical, because in EV range, where weight influences range per charge. So this product has gone through a lot of evolution. So in keeping with this evolution, just look at the bottom right product there. That's one of our latest innovations, which is just launched, which is the entire plastic window lifter, which was earlier done in steel. Today's state-of-the-art is aluminum. We designed the entire window regulator out of plastic. And this has two benefits specifically to EVs. One, the first benefit being that it is very low weight, of course. The second benefit is noise. All of you would have experienced, if you hold your mobile phone in your hand, it has a certain volume. The moment you place the same mobile phone on your desk, it amplifies, because the desk behaves like a speaker, right? So in the same principle, when you mount the motor, which is the noise-making member of a power window, on a steel frame or an aluminum frame, it amplifies. But when you mount it onto a plastic frame, the noise gets deadened. So it's using the same principle of structure-borne noise isolation. So again, it's designed for EVs. This is just an example of how even though our product did not go through an obsolescence due to the advent of EVs, it went through a transformation, right? So this is just one example. Yep. Other products we do latches, we do for the side doors, for the hoods and tailgates. Next. We do door hinges and door checks. Each of these products have their own sort of change, metamorphosis, because even though they are not influenced by the powertrain in the EVs, they go through a transformation, because you need to be lightweight, you need to be better on noise. Yeah. This is the main division that my presentation is about today. This is motors. So my father had the vision and foresight to see that we could not remain in power windows without being in the motors. Because in the year up to the year 2006, 2008, we used to buy all our motors from Japanese companies and German companies, and these companies would obviously quote much lower prices for their, for their Japanese, to our Japanese competitors or to our German competitors. So to stay alive in this business, we needed to get into motors. Now, Aditya had no experience in motors whatsoever, but my father set up a team in a separate location, and then really from ground up, hand calculations onwards, we set up the first motor completely independent without any foreign collaboration. We set it up in the Indian market. Yeah. Previous slide, Raj. Yeah. This product, just like any other product, this is a story from 2010. But like every other product that I've discussed about, this product has also gone through an evolution. You would have seen now every power window, most of the cars that you're driving, if you flick the switch with a single flick of the switch, the glass goes up. With a single flick of the switch, the glass goes down. This requires an electronic control unit to allow this to happen. Over and above that, for the noise purposes, you want the glass to go at the same speed up and the same speed down, so that you do not have feeling that going up it goes slow, coming down it accelerates and comes fast, right? So an electronic control unit is necessary for executing this. And the entire market today in motors, the ECU has been developed either by a German company, there are specifically 2 German companies that do this, or by 1 Japanese company, every single ECU. It has been a complete dependence of every customer who makes these, every competitor of mine who makes these are getting it from one of these. And this, again, the same history was repeating itself. What my father experienced in 2008, we were experiencing the same thing in 2014. Okay, now we are independent on motors, but what about the ECU, right? Now we need an ECU too. So again, taking inspiration from my father's story, we decided we will make the ECU ourselves, right? We will set up a electronics and software team. We will set up our own, R&D division for this. And we invested 4 years of our time without any customer, orders to develop what is the R&D required to make this ECU. And in 2018, we were the first company to launch power windows with an integrated ECU directly into the motor. And we still are the only Indian company with an Indian ECU today. So and this product, like every other product, is going through a further evolution. What is the further evolution? Today, there are several ECUs inside the door, inside a car. There's a separate ECU that will control your mirror fold. There's a separate ECU that will show your company's car's logo on the, welcome logo. From the mirror, it will be projected onto the ground. So your door has lights, ambient lights, switch has lights. All of these require their own ECUs. But now the next step that we have taken in this product evolution is why not integrate all the ECUs in the door inside that motor? That way the customer does not have 5 ECUs to talk to, doing 5 small functions. It's just one ECU that controls the window lift. Having had an ECU in me anyway, take over the functions of the mirror fold, take over the functions of mirror lowering. So now that is today's state of the art, that we have. It's no longer a window lifter motor. It is actually a door. It's a window lifter motor with an integrated door control module, electronics, right? So that's where we are today. Another interesting product is the headrest actuator, which is the second one from the right. This is also an interesting product, which is a German company, a customer asked us that they were buying all their headrests from their competitor. It was a similar journey that they were going through. And they asked us, can you develop a motor that will actuate our headrest automatically, depending on the drivers who sits there. So depending on the driver's eye position, locate it and locate the headrest automatically. In doing so, they said all my competitors are German companies, and please at least be on par with the German companies on noise. Do not be worse, because this is the first attempt. We took this up as a challenge, and today, I'm really happy to say that this product is the benchmark in noise and acoustic performance in all this world. So in all the competitions that happen, Mercedes-Benz, and it is very, it's a phenomenal achievement. And sir, in one point about that you mentioned about Indian engineer, I learned German to interact with my German customers. But last 2 weeks ago, I was in Germany to talk with 5 customers of mine. And interestingly, 4 out of those 5 companies had an Indian engineer who was the decision maker, who was the main person to talk to, right? So the smartest guys right now in German companies are Indians. And I was thinking, instead of learning German, I should have learned my wife's language, which is Malayalam. That would have really helped me out much more, right? Anyway, that's just a... Let's go on to the next slide. Yeah. Today, Aditya is also innovating in a breakthrough technology of a switched reluctance motor for EVs and for a different applications. Today, if you go out of brushed DC motors, the state-of-the-art technology is brushless DC motors. Now, brushless DC motors, they has one trait, which is you need to use rare earth magnets or magnets. Yeah, and rare earth magnets again has a dependency on China. So we are designing motors right now using switched reluctance technology, which only uses the principle of electromagnets, that is copper and iron, nothing, and reluctance torque to generate the motion. This is a breakthrough because it completely de-risks the dependency on China for brushless DC motor technology, right? And going forward, we are seeing a trend with automotive that EMI, EMC, and noise, and all such requirements are becoming so critical that motors are slowly moving into a brushless. Traditionally, brushed motors are moving into brushless. So this is another huge potential for us. So now we have developed a whole catalog of motors using this switch reluctance technology. This, for the government of India, is a crucial technology as well, because it reduces our dependence on China in the entire supply chain, right? Next slide. When we set up our electronics department, it was not only the electronics for the window lift. We now make the the electronics for ship controls, things to control its defense. For example, in a ship, there are 5 different engines. If one engine breaks down, how do the remaining 4 take over the function of that one engine? If 3 engines break down randomly out of this, how do the remaining 4 take over the function of this? Yeah. So these sort of ECUs, and several different ECUs. So for example, for the seat control, not very different from a window lift, taking over the function of designing the ECUs for this. So these are some of the products that we are making. Next slide. This is an organization chart. Just to this one, my father started this company in 1999, and today on the day-to-day operations, it's myself handling the technical functions. Tejas, Jayaraman. My brother handles the commercial functions, and we have a CFO, Mr. Suresh, who takes care of everything else. Next slide. Now, on our journey for NIQR, for manufacturing excellence, we can go to the next slide. Yeah. Why do we get into this journey, and what is the basis for getting into this journey? We looked at global megatrends, what's happening in the world, global warming, post-pandemic digitization, cybersecurity, artificial intelligence, inflation and inflation caused by political instability, right? And these are all some of the global megatrends. How do these global megatrends influence our automotive world in the world in which we operate in? And then based on that, we see things like shared mobility, driverless cars, zero emission technologies, e-fuels, and autonomous driving, and stricter safety norms. And based on these global and automotive megatrends, we have set up our focus areas, and we have broadly classified our focus areas into 4. Some of the examples I've already discussed about before: mechatronic systems, not just doing electrical, mechanical systems, but also doing the entire system, mechatronics, electronics, mechanical, electrical. Second one is to focus our R&D developments and our process developments on EVs and motors for EVs or motors which are solving a problem on an efficiency, which is resulting in global warming, etc. Some of the examples I will come through in my presentation. Lightweighting, of course. And none of this is possible without manufacturing excellence, because product development is one part. You also need to be, for manufacturing excellence, you need to also really get into automation, because we cannot rely on, on labor, our labor cost advantage, because like seeing the example of China's labor costs are going up. It's just a matter of time before India goes through the same thing. So how do we prepare ourselves to be future ready? We have to really invest our time and resources into automation today so that we are ready for the world tomorrow. Yeah, next slide. Another thing, I won't go through every detail here, but just to let you know, a SWOT analysis. Where is Aditya? Where are we strong? Where are we weak? What are our opportunities? What are our threats? In the Indian context as well as in the global context. This was also conducted as a basis for us to evolve our strategy going forward. This slide was, I have explained a bit of it already in before, but this is our journey. We started in 2008 with motors, and then we launched our first generation motors at 800 motors a day. Second generation of motors, which is 2014, we were producing 1,500 motors a day. 2018, we took a dramatic switch towards launching our latest generation motors with the electronics. This went up to 3,000 motors a day, and today we are still going through a very steep ramp up. Today, at this moment, we are producing 12,000 motors in a single day. Yeah, so it has been a very stressful time, but it's been a very positive stress, as I would say. Yeah. Next slide. So, of course, you need to do this. How do you manage this ramp up? How do you manage your customer expectations? How do you manage customer satisfaction? And this kind of a digital ramp up, going from 3,000 to 12,000 motors in a single day, right? So we embarked in our lean journey. Yeah, next slide. One of the things we realized is, one is to have this automation know-how in-house, and two is to be completely independent, that we build our own assembly lines, at least the most critical machines in each of our assembly lines. So we make our own assembly lines, we do our own automation, and the critical operations are all done in-house. So we started this journey way back in 2018, that we started first by building our own in-house competence. Then in the next phase, we established an Aditya production standard, so that all vendors will be able to build to the same standard, and with that we would be able to outsource more of the assembly lines and still have the homogeneity in our automation, right? So that was the second phase. The third phase was to outsource these lines, and this also we have been able to do it quite successfully, that now any line, whether it's built outside or to Aditya standards or built in-house, they all have a same homogeneous language that they speak. Right. Now, today where we are is Industry 4.0. We have automated, but the next step is, since we make our own lines, we make our own end-of-line testers, why not? An end-of-line tester does a lot of the things that we need in Industry 4.0, right? An end-of-line tester gives you the production count, real-time production count. If you just tap into this data, you can get this, right? An end-of-line tester is by nature a quality testing equipment as well, so you can easily pull out CPK data out of it, so quality data can also come out from this. And the next thing is traceability and this. So building on the fact that we built our own end-of-line testers, we built our own Industry 4.0 platform, that we connected all these ULs to our centralized server, and then now we have as well, we have made a first step, I would say, in Industry 4.0 with live production, live quality, live traceability. So this is a look at our cockpit. It's basically in a single cockpit you see all the entire production in the plant. You see which shift we did well. It is already driving a lot of decisions. For example, the first decision it drove inside Aditya, the visibility that we got, was that 12-hour shift, 12 hours into 2 makes no sense. It is much more sensible to do 8 hours into 2 shifts or 8 hours into 3 shifts because of the efficiency, because we are able to see this. We hear it, but this time we are able to actually see the bar graphs dip towards the end of the shifts, right? So it gave us a lot of visibility. This is just an example of some of the automation that we did. One of the most painful ones was to grease automatically, because our operators would always say, ultimately, to spread it to the right place where it needs to be, we need to do it by hand with a brush. But then, really, we took this as a challenge as well, that we will not let our line become manual. So then this was one of the things that we managed to do with an articulated robot, and today this has also been successful. Yeah. Then quality, let's go to the next slide. Our product is, how much time do I have? Yeah. Sure. On quality, one of our biggest challenges is that our motors are, are highly subjective in the noise. Because a power window, you have 4 motors in a car, and the end user has a very subjective criteria by which he defines it. Every OEM has a spec, this many dB, but no OEM actually even uses that spec, because it needs, all the 4 motors need to not only meet the spec, but also sound exactly the same. Because if you have one phenomenal motor out of 4, yeah, sure, yeah. So if you have one out of 4 which is slightly off, then you have, the end user would say, okay, this sounds different, so that's why it is maybe the remaining 4 are faulty, right? So we need to build the consistency. So previous slide, Rajesh. Yeah. So today's state of the art is to use not just a dB criteria, but also to use frequencies, a frequency spectrum to analyze not only the level of the noise, but also the quality of the noise. That is today's state of the art. But that is also found to be, lacking from our experience, because it ends up filtering too many good motors, right, which were otherwise good. So to really capture the subjective part of it, we are now using AI, because an artificial intelligence is excellent at identifying your handwriting, however bad it is, and then converting it into digitized text. Why not use that technology and then say, how do I convert a subjective noise into an objective criteria by which our end-of-line testers would use this? So we are right now working with the Indian Institute of Science to build a neural network to detect, to see if artificial AI can help us identify the subjectivity in the noise, and then therefore it's our dream to really make this an objective criteria to accept or reject a motor, not depend only on the operator subjectivity. With that, I'll close my presentation. I would like to thank NIQR for giving me this platform to speak, and I really look forward to interacting with all of you. Yeah. Thank you.